Okay, grade 7. If you're watching this video, you're probably stayed at home on a Tuesday because you have this for homework. If not, you're just doing it because you're, really keen. These are 9 questions that deal with area of composite shapes, the shapes that have parts taken out from them. So the first question says, what's the area of the remaining square? Well, the first hint given is that this is a square. And since this whole side here is 12 meters, then we can assume that the square would have been 12 meters by 12 meters, which means it had an original area of 144 meters squared. Now this triangle that's been cut out of it right here is a 10 by 10 triangle. That's a right angle. So the base times height divided by 2 would be 10 times 10 divided by 2, which is 100 divided by 2, which means the area of that triangle is 50 square meters. So the area of the square is 144. Take away the area of the triangle, which was 50, gives us a final answer. The remaining gray square would be 94 square meters. Okay. And if I wanted to make a formula for that, it would have been side squared, or length times width, take away base times height divided by 2. That would be the formula I could use for that one. Second question gives you a square again. So what's the area of the remaining square with a circle cut out of it? Now the interesting thing about this one is if I look at this one and I think about this radius rotated this way instead, it makes it much easier. Because if this radius was there, the radius would be 4, the diameter would have been another 4, which makes the diameter 8 meters. And a diameter of 8 meters is actually the same as the length of the square, and therefore the whole square before the circle was taken out would have been 8 meters by 8 meters, which means the area would have been 64 meters squared. Now from that 64 I need to take away a circle, and we all know that the area of a circle is pi times r, or pi r squared. Either one you can think of it. Either one's the same thing. So we're going to use pi as 3 multiplied by the radius, which is 4, multiplied by the radius, which is 4. We're going to have 3 multiplied by 16. And 3 multiplied by 16 is 48 meters squared. So the area of that circle would be 48 meters squared. And therefore, the square, side squared, take away the circle, would be what's left over. Or 64 take away 48 means the remaining area is 16 square meters is the remaining square area. Your next question is 2 circles. The first circle is cut out. The middle of this gray circle has been cut out by a smaller circle. And it says the gray ring is 2 centimeters thick. So if I was to put 2 centimeters here, okay, and then redraw, that's centimeters, redraw that gray circle, then the radius of that dark gray circle, if nothing was cut out, would have been 6 centimeters. Okay? So the first thing I'm going to do is calculate that as if it was a whole circle. So I could, as if it was this here, right? So that whole gray circle would be pi times radius squared, or pi times r, 3 times the radius, which is 6, times the radius, which is 6, or 3 times 36, which is 108 centimeters squared. That would be the area of the gray circle right here if there was nothing cut out of it. But there is something cut out. That little white circle is cut out. So that so that other circle, the white circle, is pi multiplied by the radius, which is 4, multiplied by the radius, which is 4, which is 3 times 16, which is 48 square meters. Okay? So the big gray circle without anything cut out was 108. Take away the area of the white circle, which is 48, means that the remaining area of that gray ring is 60 square meters. Your next question gives you this triangle. It says, what is the area of the gray after the square is cut out? So these 2 little ticks here, this here and here, means they're the same length. Okay? That means they're the same length. So if I look at this, when that was cut out of it, right, before that was cut out, this whole side length, since this is a square, it's 5 centimeters. This is 5 centimeters here. This is 20 centimeters, which means the whole, oh, that's not very neat. The whole length of that base, of that triangle, before it was cut out, sorry, not squared, was 25 centimeters. Okay? The height, since this is also 5 here, the height was also 25 centimeters. So therefore, base times height divided by 2 would be the area of the gray triangle, or 25 times 25 divided by 2. 25 times 25 is 625, divided by 2 is 312.5. Okay? So that would have been the area of the gray triangle before anything was cut out. But then this little square was cut out of it, and that's side squared, or side times side. The side length is 5, so 5 times 5 is 25 centimeters squared. That's the area of the square that was cut out. So you take the whole triangle, which is this much, take away that square, which is this much, and when you work it out, you would have 200 and, we better do it with a calculator. My brain's not working right now. 312.5, take away 25 is 387.5 centimeters squared is what remains. Okay, so again, just to recap, that big gray circle, gray triangle was 25. So therefore, when I substituted, I got this answer here. Take away the square, which was 25, and I had left with 287.5. The next question is a little tricky. It says, what's the area of the gray after the equilateral triangle is cut out? Well, equilateral triangle means that all of these sides are 12 centimeters long. So all of those sides in the triangle are 12 centimeters long. But in order to find the area of that triangle, I need to use this formula. Okay? So if I was to rotate this triangle here, and that's not really a great job, but we can assume that that's 90 degrees. So since it's equilateral, the base would be 12, the height would be 10. So the base is 12, the height is 10, divided by 2 is 120 divided by 2. The white triangle has an area of 60 centimeters squared, okay? 60 centimeters squared. So I'm going to take this straight over here. Oh, delete those, I guess. Take this, rotate it back. Now, what is the area of the circle itself? Well, our formula is going to be pi r squared, or pi times the radius times the radius. And since I can assume this is the middle of the circle, and that whole diameter is 12, then the radius must have been 6. So 3 times 6 times 6 will be 3 times 36. The area of the circle before anything was cut out of it was 108 centimeters squared. So 108, which is the circle, take away the triangle, which was cut out, which was 60. That leaves 48 centimeters squared of area left. And that's your answer. Your next question is a parallelogram, and there's a triangle cut out of it. So the parallelogram, if I was just to redraw it over here, since this is 22, this had to be 22. Since this is 24, this had to be 24, even though it doesn't look right, that's what it is. And the height, according to this right here, was 20. Okay? So the formula for the area of a parallelogram is simply base times height. The base was 22, the height was 20, and therefore the area was 440 centimeters squared. That's the area of the parallelogram. But if this little white triangle was cut out, this base is still 22. So it's base times height divided by 2. It's 22 times the height, which is 16, divided by 2. Take my calculator. 22 times 16 is 352. Divide that by 2. And the area of this white triangle right here is 172 centimeters squared. So the parallelogram, which is 440, take away the triangle, which is 172. I can't even do that in my head. So 440, take away, or not divided by, take away 172 is 268. So therefore, the area of the remaining gray is 268 centimeters squared. Your next question says, if the white square's area is 100 meters squared, and the gray area is 2 meters thick, what is the area of the gray? So if this is 100 meters squared, then we knew that this length here and this width here, since it's a square, had to be 10 times 10. So we know the length of this is 10 meters. Okay? So I'm going to keep that just over here for a second. Hang on a second. Let me just grab that and drag that over here. Okay. This square, I'm going to ungroup this for a second. So this square, if it was removed from there, okay, since I know that this is 2 meters thick, this is 2 meters, and this is 2 meters, and this is 10 meters. So I know that this distance here, if it's 2 meters thick, must have been 14 meters. Okay? I'll delete that. So, hang on, there we go. So when I remove this white square again, I know that this is 14 meters, and this is 14 meters. So the area of the gray would be 14 times 14, which means the gray is 196 meters squared. That's 14 times 14. Now if I bring this back in here, that was 100, so it used to be 196. Take away the 100 meters squared, which that white square is. That remains the remaining gray area of that square is 96 meters squared. The next question is Pythagoras. And for grade 7s, I don't expect you to be able to do this, but I'm going to teach you anyway. So what Pythagoras said was, if you take any right triangle and you attach squares to the sides of the 3 sides of the right triangle, this area plus this area equals this area. Okay? So this side length is 7 meters, which means the area of this square must be 49 meters squared. Since this is 5.6 meters, and if I take my calculator and go, if the side length is 5.6, then 5.6 times 5.6 is, the area of this square would have been 31.36. And 49 take away 31.36 equals, this area must have been 17.64, because 17.64 plus the area of this one, which is 31.6, has to equal the area of this one. That's what Pythagoras said. But if a square, and this is what we're looking at over here, if this square had an area of 17.64, then if I take the square root of that, and that's this button right here, the square root of it says 4.2. And what that means is 4.2 times 4.2 should give me the area of 17.64. So when I go back to that, I can actually put 4.2 here. So now I know all 3 sides, and the question says, what's the perimeter, what's the area? So the perimeter would simply be all 3 of those added together. So we got 4.2 plus 5.6, which is 9.8. 9.8 plus 7 is 16.8 meters. That's the perimeter, if you add all those 3 together. And the area would be the base times the height divided by 2, or 5.6 multiplied by the height, which we now know is 4.2, divided by 2. Take my calculator and go 5.6, the base, times the height, which is 4.2, equals, and divide that number by 2. The area would therefore be 11.76 meters squared. That's a tough one. And your last question said, what's the area of the remaining gray square? So it says square again, which we know that that means that all sides are equal. And clearly it says from here to here is 12, and from here to here is 2, which means the whole length of that square is 14 centimeters. So this is also 14 centimeters, which means the area of the gray square with nothing cut out would be 14 times 14. The area of the square without anything cut out would be 196 centimeters squared. But something was cut out, this triangle. Now, the base of this triangle is this red dotted line, right? And since this is 4, and the whole length is 14, this must be 10. So the base of that triangle is 10. And the height is that perpendicular distance to the base, which we've already defined as being 12. So it's 120 divided by 2, which makes the area of the white triangle 60 centimeters squared. So if I take the area of the square, take away the area of the white triangle, and subtract them, I get my final answer, 136 centimeters squared.